and there's just these windows, either the river running through the cave or the pools in the cave, where you're getting a glimpse into that underground aquifer. And if you had a 300-acre wildlife preserve, and the way to census the animals is there were 2 parking lots on the outside, and you could go to one or the other parking lot, stand there and look and see what you could see. And whatever happened to be near the parking lot at the same time you were in the parking lot, you discovered. Well, it's that same way with these aquatic windows in the cave passage that you're visiting. Is the cave crayfish, the cave fish, the cave shrimp going to be in that window at the same time you're looking in that window? And so a lot of it is serendipity.
Hey there, Podcast Aquanauts. It's your host, Casey here. Let me begin this latest episode of the show by wishing a hearty, happy Cave Week to all who celebrate. The discussion you're about to listen to is special in a couple of different ways. First of all, you don't actually have to just listen to it. For the first time ever, and maybe the last time, depending upon how this goes, you can actually see what a face made for radio looks like, since the episode will also be available in video form. Second, while the studio dive cage lacks a permanent home and is nomadic by nature, it has never been anywhere as unusual as the setting in which we recorded this chat. After all, where better to discuss the unique geography and ecology of caves than, well, a cave. That's right. For your listening pleasure, my guest and I endured the spine abuse of a stooped half-crawl, half-clamber across muddy rocks deep under the North Georgia hills to capture the drippy, light-deprived ambiance that only an actual cave can provide. In this discussion, the 3 of us, including a pair of cave biology specialists, one from the aquarium, one a visiting expert, chat about shrimp with no eyes, fish that navigate in the dark by sensing changes in water pressure, and why even us surface dwellers should care about how our actions affect and are affected by life underground. Grab your headlamps and a snack, and let's get to it, shall we? On with the Cavecast. Hello, and thank you for joining us for another episode of the Podcast Aquatic, the official podcast of the Tennessee Aquarium. Today, we are not only on the road, we are below the road, below the earth, underground, because this week, if all things go as planned, is National Cave Week, or just Cave Week, I think online is how it's listed. And I thought, what better way to celebrate Cave Week than by going into a cave? Because as we're going to find out in today's discussion, we happen to be here in Chattanooga, the home of the Tennessee Aquarium, in the heart of a very, very cave-riddled part of the country and part of the world. And so we didn't actually have to go too far to find a cave. And I didn't have to go too far to find the experts for today's episode either. First of all, we have, and what has become, you might as well be my co-host at this point, Bernie, but Dr. Bernie Kahida, who is our aquatic conservation biologist working out at the Tennessee Aquarium Conservation Institute. You've been on, so many episodes. The most recent one was actually, I think, just a couple weeks ago, talking about the origins of the Laurel Dace's name with Charlie Saylor. But thank you for joining us again and being willing to scramble under a very low roof to get to where we are now, which is a little bit more open in this cave not too far from Chattanooga.
Yeah, I'm glad to be here. That's the fun thing about my job. I know not all that much, but about a lot of different things. So I'm well versed in anything aquatic above and below ground.
You were the only reason I think I've ever actually been in a cave that was not maintained by the National Park Service cave. I think we went to a cave, Limrock Blowing Springs. Is that the...
Limrock Blowing Cave.
Limrock Blowing Cave, thank you. That was, almost 10 years ago at this point. And then in addition to you, Bernie, we've got Dr. Kirk Ziegler, and can I call you Kirk? Is that okay?
Please.
Kirk, you are a professor of biology at Sewanee, the University of the South, which is located about, an hour west of Chattanooga, up on top of Monteagle Mountain.
That's correct.
And you, so you're a professor of biology, but you have done some work, both of you have done work with cave species. So that's why you're on today's extra special cave episode. And thanks for joining us on the show.
Happy to be here.
All right. So I guess set the stage for our listeners. Where exactly are we, and how far in are we, and how dangerous is the situation in which we find ourselves today?
It's a walk in the park. Well, it was a crawl in the park and then a walk
scramble
in the
park.
Yeah. We are, 100 feet into the cave,
Maybe 200.
maybe 200. So we're past the twilight zone, and we're probably in the eternal darkness zone. I think it has a much more sophisticated name than that, but that sounds good.
I like it. Yeah, I like that.
And the name of this cave is?
This is Howard's Waterfall Cave, just outside of Trenton.
Okay. And that's, so again, not terribly far from Chattanooga. We got here in, a 30-minute drive, Bernie?
Correct.
So just in general, I mean, how many caves are there, like, within a pretty short drive of Chattanooga? Is Chattanooga in the middle of a very cave heavy area or part of the state?
Absolutely. I mean, everyone's familiar with Ruby Falls and Raccoon Mountain Caverns, but lots of other privately owned caves. And of course, Tennessee has more caves than any other state, more than 11,000 known caves. Alabama has something around 5,000, and Northwest Georgia has more than 500. So that's about a third of all the known caves in the United States. So it's riddled with caves is a good way to put it.
So why is that? What is it? What about our geology in this part of the country has led to there being just such a proliferation of caves in this part of the world?
Well, in order to have caves, you need geology. You need rocks that water can erode over hundreds of thousands and millions of years. And so if your rock's too hard, like up in the Blue Ridge, the Appalachian Mountains, you don't get a lot of caves because it's granite. But here in the cavers call it the Tag region, Tennessee, Alabama, Georgia, you have a lot of sandstone-capped Cumberland Plateau, but then underneath that is erodible limestone. And the water erodes through this limestone, creating underground caverns and crawlways and rivers and pools and streams and really cool stuff.
And I mean, hopefully the mics are picking this up, but maybe not. But we can totally hear just water dripping constantly all around us in the cave. It's exactly the ambiance that I was hoping for when I said let's go underground to record this. So well chosen. I think you're the one who recommended this place, Dr. Ziegler or Kirk. And have you've been to this cave before? Have you ever done any work in here? Because we haven't really talked about either of your work as far as the science you do in caves. Maybe that's a better place for us to continue the conversation. So, Kirk, you go first. What exactly have you done in terms of research in caves, and what species have you looked for?
Yeah, I study cave biodiversity and mostly focused on the invertebrates. So I like to say I study the squishy and the crunchy things in the world. So that's everything without a backbone, right? All of the invertebrates. And that's a lot of the biodiversity we find underground. And for the last maybe 15 years, I've worked in caves around the Tag region and studying the insects and the crustaceans and the millipedes and the spiders across all the different caves that we have here. And because we have so many caves, we have a lot of interesting creatures that live in those caves. And I have been in Howard's Waterfall in the past. Some years ago, a student and I had a project. We were working on caves in Northwest Georgia. And that brought us here because there are some very interesting and poorly known invertebrates that live in this cave.
Do you have any species in particular that live here that you can remember just off the cuff?
Well, one that I do remember, but I've actually not seen it, is there is a cave flatworm known from this cave that's not known from anywhere else on the planet. It was discovered here, described here, and that's one of the reasons why I came. I came looking for it on a couple occasions and haven't turned it up. But they're small and hard to find, so not too surprising that I haven't actually seen it.
So is it? I guess when you think of caves, I guess there is such a thing as caves that are fairly large and maybe connected and spanning over miles and miles and miles. But I'm guessing a lot of caves represent sort of an isolated biome, right? So are there or ecosystems? So is it true that a lot of the species you find in caves tend to be endemic to just that one cave or cave system?
That's often the case. Yeah, you can think about a cave as it's almost like an island of habitat for a cave creature, and cave creatures it might be impossible for them to move from cave to cave across the surface. They might not have eyes. They might not be accustomed to moving around out in the open. And so lots of things are isolated to a cave or just a collection of caves in a cove or a valley or on one side of a mountain. And so we get a lot of diversity and a lot of endemism, exactly, at really small scales. So like that flatworm in this cave that's not known anywhere else on the planet, there are lots of other cave invertebrates and cave fishes, I suppose, that are sort of in a similar sort of state.
Thank you for that wonderful segue, because now, Bernie, what exactly have you studied in caves? Because you've been in caves before. In fact, the two, well, we'll talk about how my introduction to the two of you after this, but what species have you looked at?
So I started getting into caves back in the early 1990s, studying the Alabama cavefish. And that is one of those cavefish. It's found in a single cave in the entire world, Key Cave, which is just outside of Florence, Alabama, in the northwest corner of the state. And I studied it, numerous counts, trying to determine if the species had been stable from some work that had been done in the 80s. And then we did a survey of caves all around Key Cave, because on our second or third trip, we discovered southern cavefish, a different species, in Key Cave with the Alabama cavefish. And all the researchers that had done work before, including the people that described the Alabama cavefish, they never found a southern cavefish. And so this is really unique, having two species of cavefish in a single cave. The only other cave in the United States that has that is Mammoth Cave.
Oh, wow. And it's obviously much bigger.
Much, much bigger, hence the name Mammoth. And so we did surveys of caves around Key Cave, thinking that maybe people just assumed they were southern cavefish in these other caves, and they may be Alabama cavefish. Well, we didn't find any Alabama cavefish, but snorkeling around and crawling around these caves, I discovered a new species of cave shrimp. So, I elbowed my way into your invertebrate world there. And that's what's so cool about caves. You never know what you're going to find, even if people have been there a bunch of times.
Well, and Kirk, you mentioned 11,000 caves in Tennessee. How many of those caves have been, explored? And I'm treating you like you're a cave expert, an expert in caving, as opposed to a biologist who works in caves. But is it typically the case that you're going into caves that have been fairly well mapped out, or are you going into a lot of caves that are recognized as caves but maybe have never really been adequately or thoroughly explored?
Most caves in Tennessee have been at least roughly described. So typically you have a description of the sort of size of the cave and what it takes to get into it, but it's not very many caves, a small percentage, have actually been fully mapped to their complete extent. So you have a general idea about whether it's real small or medium or horizontal or vertical kind of a situation, but it's rare to know. Well, it's uncommon to know exactly what you're going to end up with.
Yeah, I guess that's probably pretty exciting, though. It's kind of the gift wrapping is still on the present when you go into a cave like this to start your work, I guess, as a scientist.
I certainly think so. Usually I haven't been the first caver in a cave, but I'm not uncommon to be one of the first biologists to sort of focus on the life inside that cave, and that's always fun to explore.
What are the unique challenges of doing the kinds of research that you do in this kind of a context, in this environment where, obviously there are a lot of hazards that are unique to caves. The absence of light, I guess, is one of them. But how do you have to change your approach to doing research when you're working underground in conditions like this?
You have to recognize your limits and be cautious. Because you don't want to get into a bad situation. You don't want to sprain an ankle or break a wrist on a fall or squeeze yourself into a corner that's going to be challenging to get out of. And I think about that even more so, because I'm usually working with college students, with Sewanee students, and I certainly don't want to get any of them in an unsafe situation. So just recognizing that if something goes sideways, it's going to be hard to get out. If you need help or if you're going to just get yourself out, it's not like a walk in the woods so much. It could take hours to work your way back out. So being cautious discretion is the better part of cave safety, perhaps.
I should probably belatedly issue a trigger warning for anybody who happens to have claustrophobia, or as I looked this up in the research for this episode, spelunkophobia. If you have a specific fear of caves, this may not be the episode for you. But maybe if you saw the title of the episode, you figured that out a long time ago and aren't even hearing this. So what are your first memories of being in caves, whether that was professionally or not professionally? Were you interested in caves prior to entering them to do research, or how old were you? Where was it?
Well, I grew up in the Chicago area, Illinois, and so that's all glaciated. It's under, hundreds of feet of glacial till dirt, and so there were no caves where I grew up. Bluffs with, maybe a little overhang, that's what I called a cave. But it wasn't until I went to Southern Illinois University in Carbondale, the one unglaciated part of Illinois, where I started crawling around in some caves down in the Shawnee Hills National Forest.
Okay.
And I grew up in Maryland, and there are almost no caves there as well. The geology is just wrong. So I can recall going to a cave with my grandparents, a commercial cave in Virginia, Luray Caverns, when I was like 6 or something. But I didn't really start caving until I moved to Suwannee about 20 years ago. Just started exploring places then.
So at what point did the academic research enter into it? Were you immediately seeing the opportunities for conducting research underground when you were doing that just for fun, or how did that work its way into your career?
I've always studied invertebrate biodiversity, and so when I moved to Tennessee, I was looking for interesting opportunities, and the caves came right to the forefront. I knew there were so many. I quickly learned there was a lot of interesting things and a lot not known. Suwannee, of course, has a really large campus. There are actually about 40 caves just on the campus alone. It's riddled with caves, of course, southern Tennessee. So I suspected it would be an exciting opportunity to explore, and it has worked out that way.
What about you, Bernie? When did you start getting into caves as a scientist, as opposed to just doing it for fun?
It was in the early 90s, just doing status surveys for the Alabama cavefish, and then I got into a bunch of other caves in 1999 looking elsewhere for it. And it's doing so. Kirk and I differ that he does the terrestrial stuff mostly, and I do the aquatic stuff. In fact, I'm in a cave that doesn't have a stream in it or pools of water, so I would never...
You wouldn't work here.
I would not work here, no. But the analogy I have is that aquifer, the underground lake that is part of these cave systems. Most of it's inaccessible to humans. And there's just these windows, either the river running through the cave or the pools in the cave, where you're getting a glimpse into that underground aquifer. And if you had a 300-acre wildlife preserve, and the way to census the animals is there were 2 parking lots on the outside, and you could go to one or the other parking lot, stand there and look and see what you could see. And whatever happened to be near the parking lot at the same time you were in the parking lot, you discovered. Well, it's the same way with these aquatic windows in the cave passage that you're visiting. Is the cave crayfish, the cave fish, the cave shrimp going to be in that window at the same time you're looking in that window? And so a lot of it is serendipity.
Just chance.
Yeah.
Man. Why is it important that we even conduct research in caves? I mean, if they are these isolated ecosystems, people might look at that and say, well, if it's isolated, what impact? I mean, people are often so selfish in these situations, but what impact does that have on me? Why do we need to know more about what life is like underground? I live on the surface. How does that impact me?
I think caves are, as Bernie said, they're a window into the groundwater. And in this kind of landscape, water coming in on the surface moves underground quickly, passes through caves and streams and pools. And so it is a window into healthy or not so healthy groundwater, I suppose. And if cave populations are doing poorly, that would be the aquatic populations, but also the terrestrial populations depend on that water moving through the caves to bring nutrients in. If cave populations are unhappy or not doing so well, that's a sign that something's getting into that groundwater. And that, of course, groundwater moves out to springs and out to rivers where we get our drinking water and all of our water resources. So it's a window into that healthy or unhealthy ecosystem.
I guess it kind of goes back to what you said in that last episode I mentioned, where you and other aquatic biologists are constantly shouting about how it's all connected.
It is, and over 40% of Tennesseans get their drinking water from wells. And so if especially aquatic animals are disappearing from caves, that means it's a good chance that the water, 44%, I think is what the number of Tennesseans are drinking, is not good for them. And so it's critical, even from a selfish point of view, to monitor the life in these underground, wonderful ecosystems, to really monitor the water health for almost half of Tennesseans.
The Tennessee Aquarium's podcast Aquatic is made possible by support from the Tennessee Conservationist, the official magazine of Tennessee State Parks. Each issue is filled with fascinating stories about Tennessee's native species, rich history, and unique culture. It's also your guide to exploring state parks and planning your next outdoor adventure. Subscribe today at tnconservationist.org. Bernie, you mentioned earlier that you do a lot of your work. You were very specific on the way over here that I think I wrote this out as cave diving. You cave snorkel.
Yes.
What does that look like exactly?
So cave diving is dangerous, and I'm uncoordinated. I wouldn't make it, guaranteed. But cave snorkeling, you have a mask and a snorkel and a wetsuit, and quite often it just doesn't work putting the wetsuit on in the cave, so you have to cave in a wetsuit. So that 55-degree water feels great when you get in. And then about 40 minutes later, hypothermia is getting close, and you got to get out. But you just always have air above you, and you are snorkeling in these pools or the deep pools within a stream that's flowing through a cave, looking for these animals. They're white, and you think they would stand out great, and that's the case for a lot of cave fish and cave crayfish. But these cave shrimp, they're like less than an inch long, and they're basically see-through except for a collection of fat deposits in the middle of their body. So you're really looking for the shadow that your dive light casts on a shrimp rather than the shrimp itself. And I personally would not have discovered this new species over by Florence, Alabama, without putting my face in the water.
Kirk, are there any tools or approaches that you use to doing work in caves that would be specific to caving that you maybe your terrestrial counterparts wouldn't use?
I mean, it's analogous to what you might use in terrestrial situations, but caves are obviously, besides a no-light environment, they're a very low-food environment. And so one of the great standard approaches is to bring some kind of food bait in something smelly, something stinky, like blue cheese or tuna fish are classic cave baits. You come in and you set those out, spots around the cave, come back 2 or 3 days later and see what kind of creatures have come to the bait. So that's even more effective underground because there's so little food that lots and lots of creatures are attracted to anything smelly or tasty.
I would never have thought that would be one of the things you take with you into a cave. As we're doing this, I'm like getting distracted because I keep seeing these like flying insects in our light. So when people think of caves, I think the common go-to species that most people think of are like, I guess, bats, right? So and bears who maybe have denned up for the winter. What degree of speciation or biodiversity is there in caves? Are they more species rich than people like me who are idiots and have never really like done work in caves imagine? Is there a greater diversity of species here than you might suppose?
I think, along the lines with thinking about the endemism of cave species, yes, there are lots and lots of species in caves that aren't known anywhere else. There's about close to 1,500 species in the U.S. and Canada that are known only from caves, so not like bats that go out to the surface and come back to caves to sleep or to hibernate, but that spend their entire life cycle underground, like the Alabama cavefish, like cave shrimp, like cave spiders or cave millipedes. So that's a lot more species than most people appreciate, and that's because a lot of them have very small ranges. You might just have to go 5 miles or a few miles to find a different species of cave spider, a different species of cave beetle or something along those lines.
Okay. I mean, that to me, Bernie, immediately makes me think of darters, and like one ridge over, you might have a completely different creek or stream system and a different species than you would find just a couple miles away.
Throughout the southeast, whether it is above or below the surface, the aquatic critters that you find are highly tied with the geology. And when you get different types of rock, you get different physical characteristics in your aquatic habitats, different water chemistry, and different animals, whether it's above ground with darters or below ground with cave fish, cave crawdads, cave shrimp. And an example, Key Cave over in northwest Alabama, it's a really small cave, but it has 2 species of cave crayfish, one of them only found in 2 other caves. It's got that undescribed cave shrimp, once again only found in 2 other caves globally, and 2 species of cave fish. And then a lot of other terrestrial pseudoscorpions and beetles and spiders. And I mean, it's one of the most diverse aquatic caves in the southeast, and it's not a big cave. It's pretty amazing.
That is incredible. What's incredible to me, I mean, just looking around, and we haven't done this yet. I assume by the time we leave, I probably will say, let's just turn off the lights for just a second so I can experience that complete darkness that everybody who's ever been into a cave, even recreationally, has probably experienced that. But what's amazing is that absence of light, and as you were referencing earlier, Kirk, it's a low food environment. So how have species adapted to deal with conditions that, I mean, to me at least, seem so inhospitable? The low food, the no light. I mean, in this particular cave, you mentioned there's not a lot of pooled up water, so it feels like the water resource would also be pretty minimal. So how have species adapted to survive and maybe even thrive in places like this?
2 major things change, I think, and one of them is just the form, the morphology of the creatures, right? They typically become pale. They may lose or have reduced eyes. At least in the terrestrial things, their appendages tend to get longer. Their sense of smell may improve to compensate for the lack of light. So we see these morphological changes, and so that's what everyone pictures when you think of a cavefish, like something bright white with no eyes. That's something we see across all kinds of organisms. But the second layer, which I think is more related to the food, is going to be physiological changes. And the metabolism rates slow way down. Interestingly, alongside that, lifespans get a lot longer. If you think about surface crayfish, they might live a year or 2, but some long-term studies in northwest Alabama have shown that cave crayfish might live 25 years. So
wow.
A massive expansion in lifespan. And then they also reproduce because food resources are so low, they reproduce at much lower rates. And another interesting change is that when they do reproduce, they tend to make fewer offspring, but they have larger eggs. And those larger eggs are probably helping give those offspring a better chance to develop enough to be able to survive in that low food environment. Okay. So there's a whole suite of physiological changes that go along with the low food environment as well.
And something you mentioned earlier made me think, and I guess I'm just drawing parallels to life in the water column, but I mean, when you're in 4th grade science class and you learned about the different layers of the ocean, the midnight zone and the twilight zone and all that, I'm assuming that there must be a similar sort of stratification or spectrum, I guess, of habitual or habitats within caves, right? The closer you get to the entrance, are there different species that You mentioned bats earlier going in and out of the caves. Are there? Do you find different species closer to the entrance than you do deeper down, where maybe they're a little more isolated and not exposed ever to light?
Absolutely. Yeah, close to the entrance, you have lots of things that come and go, or that might just be hanging out because it's a cool temperature and it's moist. Amphibians move into caves, frogs, salamanders, but then they're going to go typically out to the surface to feed. But as you move deeper into the cave and you get away from the twilight zone, you get into more of those creatures that spend their entire life cycle there and never come out on the surface. And so you get into a lower food environment, typically the further in you go. So there is a sort of gradient and it's a nice analogy, right, to getting deeper in the ocean. As light decreases, food resources typically decrease, conditions get more stable. So I often think about that parallel between things that are way deep in caves to things that are way deep on the bottom of the ocean, because you're going to need a lot of sort of similar adaptations to survive and succeed in that environment, in those two environments.
Is it fair to say that neither one of you, I mentioned claustrophobia and spelunkophobia, I guess those are not something that you've had to overcome to get in the caves? You felt comfortable immediately, or was there any kind of unease to begin with?
I don't suffer from any of those phobias. Heights don't bother me either. So I never had any problems. And I did get stuck in the elbow of Elbow Cave once. It's a 90-degree turn in this cave, and my femur was too long. And luckily, we thought I might get stuck, so we had someone behind me in front of me. And I was in a wetsuit at the time, so I was starting to overheat. And I was getting uncomfortable, but someone behind me, they went to take off my boots. Hopefully, then I could get around. And then moving my feet, I was able to get around the elbow in Elbow Cave. So it all turned out fine. But that's really the only time I've actually been stuck.
Again, belated trigger warning to anybody listening to this, because my wife probably will not listen to this episode. I don't think she likes the idea of being stuck. In fact, I know she doesn't like the idea of being stuck in caves. All right. So one of the things you talked about earlier when we were talking about how species adapt to living in caves is the longer lifespan, the lower metabolism. I'm assuming that along with that, the size of the animals is also smaller. Do you find many large animals in caves?
You're right about that. Most things are small, and I assume. The southern cave fish that I've seen before are just 2, maybe 3 inches long. You don't see big fish. There's just not enough food resources to support them.
Okay.
And that's why you shouldn't be scared of the Hollywood monster movies in caves, because there's not enough food for them to get that big and eat you.
That's reassuring. Yeah. So far, the only thing I've seen in these caves are these little flies that, again, are flying around our lights. So along with that, I'm thinking, when you talk about the 1,500 species of animals that have been found endemic specifically to caves, are you mostly finding those invertebrates that are really more your area of specialization? Are those the taxa of animals that are most commonly found in caves?
Absolutely. The only vertebrates you find in caves are some cave fishes and some cave salamanders. And so the invertebrates make up, 95%, 98% probably of all the cave obligate things that spend their full life cycle underground. So yeah, there's lots of invertebrate diversity. Not that the vertebrates aren't fantastic. I'm always excited when I come across them, but there's a lot less diversity there.
So what kind of vertebrates do you find in caves?
That would be the fishes and the salamanders.
Okay, yeah. So salamanders, I guess, the other thing I was thinking of, yeah.
Right. There are aquatic salamanders. The Tennessee cave salamander is the one that is most well known around here. It's found in Tennessee, Alabama, a few caves in Georgia as well. And it actually spends most salamanders have an aquatic larval stage, and then they metamorphose and move on to land. The Tennessee cave salamander metamorphoses, it becomes sexually mature, but they stay in the water because that's where the food resources are. So they spend their entire life cycle in the water with their gills, and live for many years that way without coming onto the surface.
So in that sense, I guess, are they kind of like the axolotl? Doesn't that also have, isn't that a pedomorph? Isn't that what that's called?
That's the right term. Yeah, they maintain that larval shape while becoming sexually mature. They sexually mature sort of before they change, and they never do change into that adult salamander form that we usually imagine.
Now, both of you, Bernie, I know you have done this because the first time that I went into a cave with you was with seeing some younger fellows, I guess, so they would be the equivalent of students. When you two take students underground, how do people tend to react to being in a cave, whether that's for the first time or maybe, well, specifically, let's look at the first time. If it's their first time, how do they tend to respond to that experience, having that experience for the first time?
I think there's a pretty big self-selection before they end up underground with me. If they know they're going to hate it, they don't ask to come along because they know what we're doing. So mostly they're excited about it, in my experience. There's a weird, maybe not as strong as a phobia, but lots of students don't like cave crickets from how those, they're up on the ceiling. Sometimes they'll jump around. They might fall on you. They're totally harmless. But I've had several students who just hate walking underneath cave crickets. They get kind of freaked out about that and try to avoid it. But generally, if if we're going to look for cave biology, they're already okay with being in a cave.
Bernie, how have people reacted?
Likewise, and the caves I take students to, they typically don't have a lot of crawling, a lot of tight spaces, and especially with beginners. And even if there's just a place where you've got to maybe do a belly crawl for 10 or 15 feet, they might be a little hesitant, but there's that group bonding and group support, and people feel comfortable with other people doing it. And if they see someone go through first, they're like, see, it was easy, then you have fun with it too. Like, rather than crawling through there, I might just get sideways and roll through it and, just have some fun with it and get a little dizzy afterwards and stumble around. But yeah, you just have fun, and the group dynamic, usually everyone has fun, and everyone is really happy that they did it when they get out.
When we went, I do remember doing a pretty substantial belly crawl with what at the time was a brand new camera in a camera bag, and just kind of hoping that I could keep it above the water that was also kind of in that crawl space. So it was definitely an experience as water falls on your leg. It was definitely an experience. And I am glad that I did it, even though it was in the moment probably pretty uncomfortable physically and just very dirty. But yeah, it was exhilarating after the fact. How can people be good cave visitors? We talked about how these caves are these isolated ecosystems. They're impacted by a lot of outside activity. Obviously, when you go into a cave, you are going to have some kind of impact. So how can people minimize the negative impact they have when they go into a cave?
I think the first thing that we've alluded to already is being safe. Don't cave by yourself. Take multiple light sources. Let someone know where you're going so they know when you're coming back in case something happens. Someone's going to come look for you. Recognize your limits, because you don't want to get in a situation where you need a rescue, because that takes a lot of resources and time and brings lots of people into the cave. So safety is a piece of it. But then, sort of biological impact. The sort of leave no trace ethos to hiking or camping, you bring that to a cave as well. If you come to fragile habitats, brimstone dams or pools, staying out of those unless you have reason to be in them so that you don't stir things up. And but a small group of people moving through a cave is not usually going to be problematic. It's in most cases. If you have some sensitive habitats, I guess another place where that comes up sometimes is if it's a cave that has a lot of bats. That's generally worth avoiding, particularly if they're hibernating. You don't want to disturb them while they're hibernating. You don't want to cause them any fuss. But with 11,000 caves in Tennessee, others around, you can always choose it. You can find a different cave. Yeah, you don't have to be in a bat cave. So just choose wisely in terms of your target cave.
And some caves have a maternal colony of endangered bats, and they have their pups in the summer. So even in the summer, you don't want to disrupt those mommies because they might drop their babies, and then they're not going to make it. And but those caves are usually well known, well marked, and quite often there's a fence or a gate or something, some way to keep the public out of those caves, at least in the summer when that maternal colony is there of bats.
Yeah. Well, I guess, again, this is one of those things I probably should have let off with, but just as a disclaimer, I mean, caving is, as you've mentioned a few times, it's an inherently dangerous activity. And in this particular case, even though this is a relatively easy cave, one that is visited frequently, we did go through the proper procedure to make sure that we were permitted to be here. We signed paperwork and we're given a permit to come in and record this podcast. So we're doing this all above board. But it is something that you just, again, it's important that if you're listening to this and you're thinking about going to a cave, all the things that Kirk just mentioned, be very careful. I don't want anybody out there in the podcast Aquanaut Corps to suddenly decide that they're a cave expert and go and create one of those situations you mentioned where you have to be rescued and then inadvertently end up causing a lot of damage to a sensitive habitat or potentially hurt yourself. I mean, that first and foremost. So yeah, please do explore responsibly when it comes to caves. Another word that you often hear, speaking of caves, when you're talking about this part of the country is karst, and I don't know that I actually know what the difference between a cave and a karst is. What is a karst? Bernie, you're laughing.
Well, so karst is a general term for soft, erodible rocks that caves can be created within. And typically that's limestone, but it can also be some shales and dolomites and other geological features. But that's just a general term. And to think of it, it's kind of like Swiss cheese under the soil. And there's all these little areas for water to work its way through all these cracks and avenues in the rock down into the subterranean environment. And so everything you do on the surface, sometimes in a very short period of time, gets into the aquifer or the cave. But then some aquifer systems, like over in West Tennessee around Memphis, the water in those are 5,000 years old. So it can really vary for how young or old the water is in an aquifer, an underground lake, which is totally fascinating.
That is fascinating.
Did I get that right, Kirk?
I think I'd only say, when we talk about a karst landscape, you're thinking about areas where what you see on the surface, because it has that underlying limestone, you see caves, you see sinkholes, you see streams that sink into the limestone and disappear. You see big springs at the bottom of the mountain. So all the kinds of things that we have around here, the slopes of the Cumberland Plateau, of Sand Mountain, of Lookout Mountain, that's all going to be that karsty landscape. And it is a lot like Swiss cheese, right? Because the water's penetrating, that slightly acidic rainwater, slightly acidic groundwater is then slowly dissolving the limestone, creating small passages, big passages, giant passages. And yeah, as Bernie mentioned, the water moves through that karst landscape quickly, which is not something people often appreciate. It's not like a sponge or something that holds it and lets it out slowly. It moves through it like a subway tunnel almost. Oh, wow. So water can go in on the side of the mountain and can come out of the bottom of the mountain just a few hours later. It's almost like a water piping system.
So you mentioned 5,000-year-old water. I mean, has there been any research done, like looking at that as sort of a map of the past? Have we looked at that as looking back at the hydrology of several thousand years ago and to map changes or anything? Is that an area of research that people are pursuing?
There's a whole section at the University of Memphis that just studies that aquifer, so I'm sure that's part of what they do.
Oh, cool. Okay, so when you look back at the work that you've done in caves, what is your favorite thing that you have found or learned through working in caves that you look back on with pride, or that you're glad that you've sort of added to the academic discussion more broadly?
Similar to how Bernie described discovering this species of cave shrimp, my students and I have discovered a handful of different things that weren't known before. A couple cave spiders, one from down on Lookout Mountain, another from the Sequatchie Valley, cave isopods, so aquatic crustaceans, some cave millipedes that we've discovered that we know are new species that don't have official scientific names yet. So the thrill of finding something new it's cool. And also, several projects I've worked on, we've re-found things that hadn't been observed in decades, maybe even 50 or 60 years, where they were described back in the 60s or the 50s or the 70s, cave beetle, and then nobody had ever gone back to look for it, or nobody had found it again. And to go back, make multiple trips, sort of rediscover it, and to know that it still exists, or maybe to find it in another cave nearby. It's just kind of, I like the feeling of contributing to a better understanding of what biodiversity we have around us.
Cool. Bernie?
And then when you're in this, you realize how few biologists do this work. Mm-hmm. And I was part of the quote-unquote expert team for the northern cavefish to develop a species status assessment for U.S. Fish and Wildlife Service. And I've never collected a northern cavefish, but I was on this team because I'm a cave fish expert in general. So it's just fun being in a field that not a lot of people are involved in. And then Kirk and I together, the first time we ever went caving, well, actually the second time, on the second trip, we discovered a southern cavefish in a completely different geologic setting than they've ever been discovered before. And Kirk saw it about 3 or 4 months earlier, and he was like, I saw a white fish. And some people were a little skeptical, but after having discovered that cave shrimp about 60 miles away from any known population of cave shrimp, I'm going to believe anything is possible underground. So yeah, we teamed up and ended up catching that one of the specimens and kept it for science. Saw another one, it got away from us, but we got a nice little publication out of there.
Yeah, I remember a Sewanee student and I were in a cave in Catoosa County, not far, close to the Chickamauga battlefield, and in a pool in the back of the cave, and I'm not a cave snorkeler, so I was just standing there in my boots, looking around the room, and what I thought was a cavefish swam right past me and got away before I could get a closer look at it. But I remember going to the surface, and I texted one of my colleagues, Matt Niemeller, who's at the University of Alabama in Huntsville, who's a cavefish expert. And I said, wow, I think I just saw a cavefish over here in Catoosa County. And I remember he texted back a minute later. He's like, that's highly unlikely. And it took 3 more trips back to that same pool in that same cave until we saw them again. And of course, Bernie was snorkeling and making that possible. So that does speak to sort of, it can be hard to find these things. And if you're not there at exactly the right moment, you certainly won't know that they're there. It was just sort of luck that it happened to pass by my foot.
Yeah, this was back in 2017, and I actually, that was
2015 is when you saw it.
Because the story I wrote about it was in 2017. Mm-hmm. I will link to that in the show notes, because that was the first time I think we didn't actually speak. I think I emailed you questions that you responded to, but it was a really interesting. It's the first time I'd ever heard the word bioprovince before, so I learned a lot just in covering that story, because that is just so interesting. Because, like you said, you just never know what you're going to find down here.
Kirk, I believed you from the get-go.
No, I remember you did, and I appreciated that, because I had gone back a second time and hadn't seen it, and I was feeling more nervous, like, oh, is it just like a pale minnow, and maybe I had it wrong. Because, as Bernie mentioned, this is the southern cavefish, which is known from Kentucky, Tennessee, Alabama, and a few caves in Lookout Valley, right on the west side of Lookout Mountain. But we were over on the east side of Lookout Mountain, and that's what made it so surprising that we had pushed over where southern cavefish had never been reported from anywhere east of Lookout Mountain or east of Walden Ridge. And that's why, of course, Matt thought he thought I had it wrong, and it was probably a good bet that I did have it wrong.
He had good reason to think that.
He had good reason to be, and I didn't even appreciate quite the geography of the distribution at the time, I think, to know how surprising it was. But I was pretty darn sure I knew what had passed me by, so we persisted and eventually confirmed it, which was neat to do.
It was.
Well, I hope that everyone who's listening to this has enjoyed going underground, if not exceptionally far into this cave here in North Georgia. But as we wrap this up, I would just like to ask, are there any blank spots that exist within our understanding of cave biology that you're excited for to be working towards illuminating or focusing research on uncovering in the years to come, or that maybe other people are working on that you're interested to see what comes of that work? What do we not know about caves that's academically that you either want to work on yourselves or that you're excited that other people are working on?
Two things that come to mind that I'm most interested in, and one is, we touched on the idea of these changes in morphology. They get pale, their antennae get longer, their sensory systems change, and the physiology changes. But we don't have a good grasp on what's happening genetically, sort of under the hood there. And of course, this is happening, it's happening in fishes, it's happening in salamanders, it's happening in beetles and millipedes and spiders. So all these different groups are experiencing this same ecological challenge of sort of no light, low food. And I'm curious to know, are the similar kinds of genetic changes happening, or are these creatures ending up with these cave forms in different ways or in the same way? So that, in terms of extending lifespan, in terms of slowing down metabolism, in terms of losing pigment, I think that will become is already becoming more answerable as we get more and more genetic and genomic information about more of these creatures. So that's one piece that I'm curious about. And I think in the next decade, we'll get a much fuller picture of what's going on there across all the sort of cave biodiversity. And then the second one we talked about later, is thinking from a conservation standpoint, how much do we worry or focus on these often very poorly known, very limited range species? How important is the cave millipede? How important is the cave flatworm from this cave that's never been seen anywhere else? Is it as important as a rare bird or a rare fish on the surface or a rare, a plant in the forest, or not, right? So that's not so much a scientific question as maybe more of a policy or a sort of ethical question. And I think that's a complicated one to think about, how important is it to human life? How important is it to our ecosystems or our understanding of the history of life and biodiversity? So interesting questions there that I think are not fully answered and are considered in different ways in different parts of the world. So that's a second area that interests me.
Bernie?
Going back to the genetics, because all cave organisms kind of do the same thing morphologically, they converge to the same body shape. And so there are probably at least 10 distinct species, what are now called southern cavefish. And there's 10 different lineages, at least right now, that Matt Niemiller at University of Alabama, Huntsville has recognized through genetics work. And some caves may have more than one species. We look at them and say they're all southern cavefish, but they may be different species other than the southern and northern cavefish in Mammoth Cave and the Alabama and southern cavefish in Key Cave. And so as we continue with the genetic studies of these animals underground, we're going to get a better understanding of the diversity may double or triple, because just using morphology, they kind of all look the same when they're related.
Well, I mean, clearly there's a lot that just about caves in general that we don't know about in terms of their shape and their formation, how large they are, and obviously, just from what you two just said, a lot we don't know about what lives down here. So I guess with that, we can go ahead and wrap up this special on the road and underground episode of the podcast Aquatic. And happy National Cave Week, or happy Cave Week to the two of you and to everyone who's listening. And if you are listening to this and you have an idea for another episode of the podcast, go ahead and email that to me at podcast@tnaqua.org. While you're online, go ahead and leave us a rating or write us a review. Both of those are free and easy ways to support the show. If you have a question for an expert like Bernie or like Kirk, you can email that to me at that same address, podcast@tnaqua.org. And in the meantime, until next time, remember that every drop matters.